So the reflection rules that we're going to be using today are given to you right here. I am not expecting you to memorize any of these. You will always be able to use these rules. My bigger concern is that you're able to apply them. Okay, so the majority of these are pretty straightforward. If we're reflecting something over the x-axis, we've got this coordinate plane. So we have a coordinate plane here. And if we're reflecting something over the x-axis, it would be this axis right here. So our values that are changing would be the y values. So you take your original x, y coordinates, and your x's are going to remain exactly the same, and your y values would become opposites. Okay, so this is definitely something that you covered in Algebra 1. It's also something you covered in middle school. So we are not spending a lot of time with this, but I do want you to understand the application of the mathematical rule. Okay, so over the y-axis, if we're reflecting something over the y-axis, we're reflecting over this axis here. So if we have a triangle, it would simply be equidistant from our line of reflection over the y-axis. So we would have this point here reflected would be this point right here. Okay, so everything, your x value and y value would become the opposite of your x, and then the same y. Okay, so the only thing that's changing is where it's located on the coordinate plane, so it's going to be in the opposite x direction. So over the line of y equals x, you're going to follow this rule, but the one I want to concentrate on is over a vertical line. So if you're given over a vertical line, and you're given one of these on your worksheet, if we're told here that we've got x, we're reflecting over the line x equals -2, okay? And so because we know x equals h, by substitution we can say that h must equal -2. Okay, so we've got these three ordered pairs, and we can just name them, and I'm not exactly sure what problem this is. But if you look at your worksheet, you'll be able to find it. We're going to use the rule that says xy is transformed to 2h minus x comma y. Okay, well h is -2, so if I substitute this in here, I have xy, so I have 2 times -2 minus x comma y. 2 times -2 is -4, so I have -4 minus x comma y. So now this is my mathematical rule. So I'm going to go from an ordered pair of xy to the mathematical rule of -4 minus x comma y. So if I label my ordered pairs, let me find this worksheet. This is problem 10, guys, on your worksheet for today. So if I label my ordered pairs, I've got S, T, and R. And S is at the ordered pair of -1, 1. T is at the ordered pair of -4, -3. And R is at the ordered pair of 0, -4. Okay, and these are my givens. These are my x, y. These are my given values. And so I'm going to go through this rigid transformation, and I'm going to apply the rule of -4 minus our x value to give us our new x value, and then we have our current y value. So S prime, we would say, let's do it over here. I'll do a different color. We're going to say -4 minus a -1, because that's what our x value is. So -4 minus a -1 would be -4 plus 1, or -3. So my ordered pair for S prime would be at -3, and then my y value is going to remain at 1 because these are not changing. Okay, T prime is we're going to use the rule here of -4 minus a negative 4. Negative 4 minus a negative 4 would be negative 4 plus 4, or 0. So my x value is at 0, and my y value is unchanging. I don't know why I put a 0 there. My y value is unchanging. So that's going to be 0, comma, negative 3. So t prime would be at the ordered pair of 0, comma, negative 3, or that location. Okay, and then r prime, we've got negative 4 minus 0, which is negative 4. So my x value is going to be at negative 4, and my y value remains unchanged at negative 4. Okay, so I want you to be able to apply the rules, and mathematically you are capable of doing that. So just give this a shot. Again, I want you to use a colored pencil to show that you've translated the object, or you didn't translate, your transformation, to show your transformation. Okay, I'm sorry I'm not here with you guys today. I'm sure you'll do great, and we'll cover this again on Tuesday when we get back from break. Thank you.